Our next speaker, Dr. Mark Siemens, is an associate specialist and professor in the Agricultural and Biosystems Engineering Group at the University of Arizona, Yuma. His program focuses on developing and evaluating machinery for vegetable and fruit production, with the goal of reducing labor requirements and lowering production costs. He is the holder of one U.S. patent and is currently developing and evaluating the performance of automated thinning machines for lettuce. Today, he is going to speak to us about the point injection systems designed to apply fertilizer and pesticide in the field.
Thank you, Robert. Great program. Thanks for having me. My name is Mark Siemens, and appreciate all the participants that are still out there. I know it's been a long day, and I don't know about the rest of you, but I'm ready for dinner here. So go ahead and get going. As Robert mentioned, I was going to talk a little bit about point injection systems and some of the experiences that we've had with them. Had a lot of discussion today on soil health, and as you guys know, soil health is basically inversely proportional to the amount of tillage we do, and vice versa. Here in the Yuma area, we do quite a bit of tillage in preparation for vegetable production. The reason we do that is vegetable seeds tend to be quite small, and we need a pretty nice, finely prepared seed bed in order to get a good stand establishment. If we're gonna get to reduced till or no-till environment and try and produce vegetable crops, we're gonna have to change a lot of things. Not only our production practices, but we're also gonna need some new equipment to have no-till lettuce. And one of the tools I thought might be a good fit for this was what's called a point injection system. And what these systems do is they inject chemical liquid materials into the root zone with minimal soil disturbance. Pretty simple system. There's a high pressure fluid line that delivers fluid right to the axle of the rotatable wheel, and then the fluid would exit through these injection spikes. Here's another depiction of that. The hub is actually it's a fairly clever design. It has a metering sleeve in the hub, and it's designed such that liquid is injected only when the point or the injection spike is in the ground. There's a couple of commercially available manufacturers of point injection systems. These devices were actually invented or patented about 30 years ago, and they're still being manufactured today. I don't have a lot of experience with no-till vegetable production and point injection systems. However, we also thought that there would be a fit for point injection systems in our conventional lettuce production. And one was for side dressing or applying fertilizer to our crops. As you guys know, this is commonly done with a knife or a shank type injector. And a problem or limitation with this is getting that material close to where it's needed in the root zone. I don't know how well it shows up on the screen, but you can see the roots of the lettuce plant here. They actually extend all the way out to the point where we're applying the fertilizer. And our hypothesis was that this technique was doing some root pruning, some sidewall compaction, and therefore limiting our uptake and growth. So put together a project to investigate the use of point injection systems. Basically, what we would do is angle them kind of perpendicular to the bedside wall, and then inject the fertilizer directly into the root zone at specific intervals and depths. We also thought, as John mentioned earlier today, that some of our systemic soil applied herbicides are pretty immobile in the soil, and we thought that there might be a fit for this technology with those type of products. So we set out some experiments to look at this, comparing the standard knife injection system with the point injection system. We looked at applying our full complement of fertilizer, and we also looked at deficient rates of fertilizer. The evaluations we took were mid-rib nitrate nitrogen levels, yield, and we did this over the course of 3 seasons. I have a video here of system operating. And you can see here the puncture holes. I forget exactly what the interval there was, maybe 8 or 10 inches apart. Here are some of the results. These are the mid-rib nitrate levels after the first side dress. On the horizontal axis, you can see the percentage of the standard rate of nitrogen that was applied. You can see here that we had a pretty significant increase in nitrogen uptake with the point injection system as compared to the conventional knife blade applicator. In fact, about a 17% increase. What was also interesting to note with these results is that at the 25% of the standard rate of applied N, we saw no significant difference between that and the full complement of fertilizer applied with the shank applicator. At maturity, again, we saw some pretty large and significantly differences between the 2 fertilizer applicator systems. And again, here in again, no difference between the point injection system at a deficient rate and the full complement of fertilizer. As far as yield goes, we saw some significant, about 11% significantly different yield difference at our deficient rates of applied nitrogen. And what was kind of interesting too, if you examine this data closely, you can see that there's about a 9% increase in yield with the point injection system at the 50% rate of applied N versus the 75% rate of applied N with the knife blade injector. And again, here at our 50% applied rate, we didn't see a significant difference in terms of yield when we used the point injection system. So to summarize real quick, here at the 50% standard rate, we saw a significantly improved nitrogen uptake. We saw some yield increases, and we also saw that that the results are showing that we could reduce our applied nitrogen rates somewhere between 25 and 50% and maintain yield. These results were pretty encouraging, so we worked with some growers to try the system out, see if this would scale to commercial fields. And we had some mixed results. One of the reasons was in some of the fields that we went into, the field had been cultivated and had dried out. In some of our heavier soils, our soils get really almost rock hard. And in that case, the point injection system wasn't able to penetrate into the soil, into the bed profile. And basically we ended up placing the fertilizer essentially in the same location as you would with a conventional knife blade applicator. Where we did have good success is in fields that had not been cultivated. And you can see here from this slide that the injection spikes were able to penetrate the soil quite easily and inject the fertilizer into the root zone as we intended. So based on this observation, we wanted to kind of prove that out and conducted some formal research studies. And basically, we're comparing the standard conventional knife blade applicator with the point injection system. We looked at doing this in broccoli and romaine crops, and conducted a trial similar to the previous one. Again, applying the full rate of fertilizer and looking at deficient rates of applied fertilizer, and then looking at the nitrate levels in the crop and also crop yield. These are the results after the first side dress with broccoli crop. You can see we got an excellent nitrogen response to applied nitrogen. We also got a significant increase in nitrogen uptake using the point injection system as compared to the conventional applicator. As far as yield goes, again, we saw an increase. These differences were not statistically significant, but there was a fairly significant or observable trend there that we were seeing in yield increases. With the romaine, we saw no difference in nitrogen uptake. However, again, we did see some yield increases, in this case, numerically about 8%. And again, these differences were not statistically significant, but it did look like there was a definite trend there. So to summarize, again, as in our previous studies with iceberg lettuce, again, with broccoli and romaine, or I guess with broccoli, we did see significantly improved nitrogen uptake. And then we did also see some trends towards about a 8 or 10% yield increase. I'd like to switch gears here a little bit and talk about our work with point injection system as a pesticide applicator. Again, our interest here is with pesticides that are systemic and highly immobile. Coragen is one of these products. As you guys know, this coragen is typically applied at planting directly under the seed. The activity lasts for about 28 days after the wet date or after seeding. And our hypothesis here, or what we wanted to test in this trial, was to determine if we could apply this material after seeding 26 days and see if this technique might be a viable technique to get some material in the plant and provide some pest control. Here, the slide showing the results of this trial. basically you can see here, I don't know if you can see my mouse, but basically we had some different rates of applied coregen. The y-axis is the coregen concentration in the second true leaf of the plant. You can see here that it increased over time and then fell to about the level of the untreated control right here at about 25 days, as you might expect. At 26 days after seeding, we made application of coregen with the point injection system, and you can see this pretty nice response to that application. What was particularly encouraging in this trial was that that material was translocated to the new growth of the plant. This slide is showing the coregen concentration in the 5th true leaf. Down here at the bottom are the applications we made at seeding, and you can see the pretty high levels of material in that new leaf tissue. We also did some work with Savanto in melons, and have a short video here. We applied this, I believe, 39 days after seeding. As John mentioned, getting a mobile pesticide into melon crops is challenging and not done frequently because of the root pruning issue. Here's the results of the trial. What I'd like you to focus on here is these highlighted results. What this treatment was applying scorpion at the time of planting and then making an application of Savanto 39 days after planting. If you compare these results to applying Savanto or scorpion at planting, you can see some pretty dramatic numeric differences, and in some cases statistically significant differences. And then applying the same two products 39 days after planting, again, some pretty substantial and statistically significant differences in whitefly population and incidence of CY SDV. So to summarize, basically point injection systems, kind of one more time, are designed or intended to deliver chemicals in the root zone with minimal soil disturbance. Conducted series of trials where we found that the devices improved nitrogen uptake and increased yield, and also demonstrated that the device is effective for applying highly mobile systemic pesticide chemistries post-emergence. How are these systems, as I mentioned, these systems have been around for a while. Where are they used commercially? I know some growers up in Oregon are using them in wheat to make post-emergence application of fertilizer. Just showing this slide, the system also can be used in row crops. And one application I thought might be interesting for this technology would be in alfalfa, maybe to apply phosphorus, which is immobile. It could also be used for applying insecticides or pesticides. So I'm showing this video. The devices haven't gained a lot of commercial acceptance. Where I talked to the manufacturer, and he said his biggest market is actually in the turfgrass industry. used in golf courses and whatnot. And that's all I had, Robert.
On behalf of the University of Arizona, Yuma County Cooperative Extension Group, I thank you for attending the Desert Southwest Soil Health webinar. All of our speakers and myself hope that you've enjoyed the webinar and found the material valuable. Our webinar was designed to encourage you to make healthy decisions with land management choices. It is our unified desire that the knowledge shared with you leads to many bountiful harvests on your farm or your home garden in the years to come. Once again, thank you for attending our webinar and allowing us to speak about the things in life that we are most passionate about.